In this question, we have an electron and a proton, both have the same charge, the magnitude, simultaneously released from rest in a uniform E field. So we have this drawing here. So what will be the same after a certain time? So let's work things out. In terms of acceleration, right, see, what's accelerating this guy? You will have, right, net force equal to ma. The only force will be the electric force, so it will be E times of the E field E, which is a constant, equals to ma. So we see that A is equals to some constant EE divided by m. So A is actually proportional to 1 over m, inversely proportional to mass. Yeah. So we know that the electron will hence accelerate at a higher rate. Okay. Then right, that will mean that a while later they wouldn't have the same acceleration, and certainly right, they wouldn't have the same velocity. So A and D are out. What about the KE? For KE, right, you recall the change in KE will be equals to the net work done. Okay, this is the work energy theorem. Who is doing work on this guy? Well, sorry, let me just write the KE as such. KE final minus 0. Is the electric force doing work? So it will be the Fe times the distance. Okay. But we note that the electron will have a larger acceleration, larger velocity later on. Okay. So it must have also moved a greater distance. Okay. Hence, right, the distance moved by the electron is larger. So KEF is proportional to D. So electron will have a larger distance. So electron will have a larger final KE. So this one will be not the same as well. We're left with simply the answer, magnitude of momentum. But how do we know that? So we see that another version of Newton's second law, okay, net force equals to dp dt. Okay, another way of writing this is to write it in terms of the impulse formula. So the area under the graph for the ft graph will be equals to the impulse or change in momentum. Since, right, this graph, this force, right, is the same for both. Okay, thus, right, change in momentum will also be the same. Yeah, and they both start with 0 momentum, so they will end up with the same momentum later on. So answer will be B.